Hello, I'm Kentaro Wada, a PhD student at the Imperial College. I present our work on object picking in Clutter, where target object can be occluded by other destructor objects, and robots have to deal with these destructors to safely and efficiently complete the task. Our system, SafePicking, meets these requirements by learning, so that robots can extract objects with minimal disturbances to the other objects. When a robot is tasked to pick an occluded object in a pile, there are two major approaches. One is the occlusion removal by detecting and moving all of the destructor objects. This approach provides safe manipulation without causing collisions among objects. However, it can be inefficient when there are many layers of object overlap. Another approach is the direct extraction of objects with motions such as upright lifting. This is efficient and works when the gripping is strong enough. However, it can cause undesirable disturbances that can damage or drop objects out of the workspace. To meet both requirements of motion safety and efficiency, we adopt a learning-based approach, which extracts the target object with a single grasp while maintaining the original configurations as much as possible. A typical pipeline for target picking consists of pose estimation from camera images and motion planning. We applied two changes to this pipeline. We first replaced the hand-coded planning with learning so that the planner can generate optimal motions via training with a safety metric. We trained this model in simulation using object CAD models and their translations as a safety metric. Instead of just using the estimated object poses as input, we also feed raw images to the model. This multimodal information allows the model to acquire semantically rich information from the pose input, but also robustness to the estimation errors from the raw images. This figure shows the overview of our actual pipeline. For pose estimation, we create a map of objects with their geometry and poses using the state-of-the-art visual object mapping system, which incrementally builds a map using an onboard RGBD camera. For learned motion planning, we use deep Q-learning for training via safety metric as a reward. This learning model produces the 6-dot transformations of the end effector, which construct the arm trajectory. As the input of this model, we retrieve object poses and the height map from the object level map. We compared our learned method against baseline alternatives. The learned model generates motions that push objects if necessary, while avoiding unnecessary collisions or object drops. Here we show the effectiveness of multimodal inputs. The left model only uses height map as input, which is a common setup of learning-based manipulation, whereas the right model uses object poses as well. The model with multimodal inputs shows better motions with awareness of object shapes. We have more evaluations and examples in the submitted paper and video, so please check out for more details. Thank you for listening.